So again, we are going to have a joint probability density function. This time, x and y, they are representing the profitability factor or the return rate of two different investments. So both x and y can only take values which are greater than or equal to 1, okay? So they cannot take any value that is less than 1 because these are profitability factors. They cannot be less than 1. So if you invest in a project, the profitability factor should be greater than 1 if it is going to bring any profit. However, I mean, of course, some projects are risky. Sometimes they can bring a return which is less than 1. But in this case, in this example, we assume that both projects are profitable. They are going to return a factor which is greater than or equal to 1 in both cases, according to these joint probability density function, which is 1 over x squared y squared. Now, please be careful here. Both random variables here are defined on the same region. Both x and y are greater than or equal to 1. And similarly, the contribution of x and y values in this function are the same. They are both in the denominator as a multiplier, and they are both squared. So which means here, the marginal PDF of x and the marginal PDF of y, they should be the same. If their marginal PDFs are the same, then their marginal CDFs should be the same as well. In fact, their expected values and the variances should be the same as well. Now, let's check it out. In part A, it asks me the marginal PDF and the marginal CDF of x. Once we compute the marginal PDF and the marginal CDF of x, we are going to use the marginal CDF to compute that probability. The probability of the first investment to have a profitability factor to be between 1.2 and 1.5. So in the second part, this time we are going to determine the marginal PDF and the marginal CDF of y, and we are going to compute the probability of the profitability factor of the second investment to be between 2 and 2.5. And finally, the third part, which is a little tricky this time, we are going to find the probability that the profitability factor of the first investment to be at least 2 times larger than the profitability factor of the second investment. So the probability of x being greater than or equal to 2y, it says, which means the probability of the profitability factor of the first investment to be at least 2 times larger than the profitability factor of the second investment. Okay, if you are asked, I mean, we can ask this question to you in that manner. So I can, for example, say, what is the probability of the profitability factor of the first investment to be at least 2 times larger than the profitability factor of the second investment? That question is exactly asking that probability. Okay, so you need to be very careful in reading statements and converting them to the mathematical expressions. Now, before solving any part A, B, or C, let us illustrate this joint PDF in third dimensions using a 3-dimensional plot diagram. Of course, in the homework, in the exams, I am not going to ask you such questions because it is very hard for a person to draw a 3-dimensional function. You need to be very careful about that. However, in the homework, maybe I can ask such a question, okay? An easy one, maybe. Not a hard one, but an easy one. Now you see, my function is this. When my variables x and y are taking values which are greater than or equal to 1, in that case, my function is calculated like that. But in every other part of this function, the function is equal to 0. In fact, you can see it here, okay? So for values that are less than 1, when x is less than 1, for example, here, and when y is less than 1, the function is simply 0. Otherwise, the function is equal to 1 over x squared y squared. This function can be maximized when x is equal to 1 and y is equal to 1. When x and y are equal to 1, this function is going to be equal to 1, as you can see here. Then, as x increases and y increases, in the second order here, the function is going to converge to 0. And you see it has a shape like this. and the total volume under this function is equal to 1. In fact, we do not need to calculate it, but you can calculate by taking the double integral of this function with respect to x and y, and the boundaries should be from 1 to infinity in both cases, and that result is going to give you a 1. The total volume under this function is equal to 1. So this is just made for illustration purposes, so you can understand the behavior of the joint probability density function in the third dimension. Az önceki soruda da 3. boyutta çizemedim dedim ya, sadece tabanını çizdim size. Burada ise 3 boyutlu bir şekilde fonksiyonu çizebiliyorum. Şimdi bana sorulan soru şu. We are going to determine the marginal PDF and marginal CDF of X, then we are going to calculate that probability. So marginal PDF of X is going to be computed by integrating the joint PDF over Y operator from 1 to infinity, because random variable Y is taking values from 1 to infinity. And that is the integral of the joint PDF. Now I am rewriting my joint PDF in that representation, x to the power minus 2 and y to the power minus 2, so I can integrate it easily by using the integral of polynomial. Now, remember what we are doing. If we are supposed to integrate with respect to y, we are going to increase the order of y by 1, and we are writing that value as in the as a multiplier in the denominator of a multiplier, right? So that integral is going to be minus x to the power minus 2, y to the power minus 1. And when I plug in y values as infinity and 1 here, now I am rewriting that integral, the result of the integral, like this. If you write infinity in place of y, you get 0. And if you write 1, you get minus 1 over x squared. And the difference is 1 over x squared. So 1 over x squared is the marginal PDF of x, and for values which are greater than or equal to 1. Now I am going to compute the marginal CDF of x. How do we compute that? Remember, now if I have the marginal PDF, the marginal CDF of x at x is the probability of x to be less than or equal to x. And because the least possible value that x can take is 1, we are basically integrating the marginal PDF from 1 to x, however, by changing the integral operator and the variable to t. So this is, instead of 1 over x squared, we have 1 over t squared dt, and that integral is going to be equal to 1 minus 1 over x. So this is the cumulative distribution function of the random variable x. So we have computed the marginal PDF and the marginal CDF for x. Now, the last part is this. What is the probability of the profitability factor of the first investment to be between 1.2 and 1.5? And remember, for continuous random variables, such interval probabilities can be computed by subtracting the cumulative distribution value or cumulative probability at the lower bound. Okay, so the lower bound is here. And we subtract the cumulative distribution function at the lower bound from the cumulative distribution function at the upper bound. So we calculate the CDF at 1.5 and subtract the CDF at 1.2 from that. And let's calculate the CDF at 1.5 and 1.2 in both cases. This, at 1.5, it is going to be 1 minus 1 over 1.5, which is 1 over 3 here. At 1.2, it is going to be 1 minus 1 over 1.2, which is going to be equal to 1 over 6. And if you subtract 1 over 6 from 1 over 3, you get 1 over 6. So that probability is equal to 1 over 6. Now, in the second part, the question asks to find the marginal PDF of y and marginal CDF of y. However, I am not going to do that because, as you can see, both of these random variables can take the same values. So their domain are the same, the domain of the values are the same, and their contribution in the joint PDF are the same. Therefore, whatever we find as the marginal PDF and marginal CDF for x is going to be the same for the marginal PDF and marginal CDF of y. So we can easily write that the marginal PDF of y is 1 over y squared for values which are greater than or equal to 1. And the marginal PDF of y is going to be, marginal CDF of y is going to be equal to 1 minus 1 over y. and the probability of the profitability factor of the second investment to be between 2 and 2.5 is the CDF of y at 2.5 minus the CDF of y at 2, and that is 1 minus 1 over 2.5, which is a 3 over 5 or 0.6 here, and the CDF at 2 is 0.5. 0.6 minus 0.5 is 1 over 10, 0.1. So we can calculate that probability again.